Okay, let's talk about how to graph using the delta math tool. Let's first talk about the parts of an exponential function before we get into it, so you can um, know what role each of the pieces plays. The first one is the base. And this is the base of the exponent. Um, but think of this as the growth factor, okay? Which makes this the a that's multiplying to the b, but is not affected by this exponent. This makes this kind of like the initial value. So in the financial examples we had, maybe you started off with $100 and it grew 5% every year, right? So this would be A, this is B. But maybe before even started, you started with a $50 bonus, right? This would be the D part right here. Anyways, the exponent plus this, this is the inside. Well, actually, this is the inside of the function. This is what changes. The exponent and the base interact with each other to make change. And x is the exponent, but it's also, you often think of it as time passing on. But this plus c, I'm going to talk about it graphically. The plus c is, I'm going to start to say, horizontal shift. This is a horizontal shift on the inside of the function. And guess what? Even though this is the initial value, this is a vertical stretch. Or reflect, stretch or reflect. A can be negative, in which case it'll flip the exponential function upside down. But this here, the plus d, this is very important because this is your horizontal asymptote. Okay, let me quickly draw a basic exponential function. The shape looks like this. Okay, the domain of this exponential function is negative infinity to infinity. Never stops going this way, never stops going this way. And every exponential function has an asymptote. The basic one, which I'm kind of sketched here, is 2 to the x. But this growth factor can be, can be anything. Here's the other thing one more thing before we check out the delta math. This can be a growth factor, but it can be an anti-growth factor. It can be a shrink factor. The math word for it is decay. Okay, it's anti-growth. And how do you create anti-growth? Well, you saw that in the financial stuff. Here's an example of anti-growth. It's cutting your money in half every year. What money? It's the money that you started off with. Maybe it's $1 and it's sitting right here. Okay, so this is going to make your money disappear over time. Okay, so that's what that'll look like when you have a base that is less than 1. So these are all important facts to know when you're evaluating or you're kind of assessing your graph. But the actual protocol for doing the basics of the graph is really a 3-step process. Okay, so we're looking at a fairly basic function. 3, here's our a, is 3. Our b is 2, and there is our exponent, and then plus 1. Okay? This, the constant factor, the constant outside of the constant term, I think we should say, is your horizontal asymptote. This is the floor. And so when you do this in delta math, you're going to, for every exponential function, in fact, you're just going to say it's horizontal. And since the d is plus 1, you're going to raise this up to here, up to the plus 1. That's going to be your first step. Your second step is you're going to play a little trick. And the trick, which is really designed to make your calculations easier, is to make the exponent equal 0. And you make the exponent 0 so that you can calculate the y easily. But to make the exponent 0, here y has got to be 8. I'm sorry, x. X has to be 8. Right? Notice right here. And when x is 8, let's calculate the y. We're getting 3 times 2 to the, well, now it's 0, plus 1. That's our y. Well, 2 to the 0 is 1. So y is 4. And so the point that we're going to, the first of 2 points that we're going to use is 8, 4. So let's drag this over to 8 and go up 4. 1, 2, 3, 4. That should do it. Sorry, I think I made a mistake here. Having the x equal 8, that will make the exponent into a 1. So exponent, the calculation was wrong. So it would end up being 2 to the 1, which is just 2. And then 3 plus times 2 plus 1, the y would equal 7. And so that's my mistake. So these are the two points that you're calculating, making the exponent into a 1, and the others to make the exponent 0. Okay, but I have to replace the point. Okay, I think we're back on track. Your second trick is to make the exponent 0, and this is where x gets to be 7. And once we've made x 7, we're going to have, oops, that's weird. Y equals 3 times 2 to the 0, since 7 minus 7 equals 0, plus 1 equals, well, what is that? This is just 1. 3 times 1 plus 1 is 4. So the second point we're going to draw is x equals 7, x equals 7, y equals 4. So let's drag this from x equals 7, y is 4. And the things that I would check before hitting submit are real simple checks. First of all, is it growing? Because your growth factor is 2, not it's greater than 1, so yes, it should be growing. Make sure that you've got the horizontal asymptote placed in the right place as a positive 1. And then lastly, if this 3, since it's positive, it's not going to reflect. Had this been negative 3 instead of positive 3, this would cause a reflection, and a reflection, like literally, if I made this a negative 3 instead of 3, it would look like this. So, which can be confusing because the 2 is your growth factor, but if it's reflected, which you'll see in some other examples that you do, it's actually the graph is descending. But it's descending because reflection just kind of like inverts things and sends you to opposite land. Okay? So, but in any case, I think we did these 2 points right. And now let's take a check. Okay. Okay. So here's one with a decay factor. See this half? This is not growth. It's the growth factor is anti-growth. Okay? It's going to go down. This is if that's what you do to your money every year, your money's going down. Okay? So look for that. It's for the graph to be going down. And the one other check to make sure you have your intuition right is this. As long as this is positive, it's not in upside down land. Okay? So the growth, it's going to go down because it's going to be on the, another way to know this is that it's going to be above the asymptote. If this factor is positive, it's going to stay up here. The graph is going to stay up here and it's going to descend. Had this been negative, if this had said -2 instead, it would reflect that anti-growth, and you'd see this sort of shape below the horizontal asymptote. Okay, so those are all just hypotheticals. But we're still going to use our 2 methods. We want the exponent to equal 0, and we want the exponent to equal 1. And we're going to choose our x's accordingly. So for this scenario, x is going to be 5. For this scenario, x is going to be 6. Okay. So what happens to the function when x equals 5? You get 2 times 1/2 to the nothing minus 5. What is that? Well, this becomes your 1. So 2 times 1 minus 5. Looks like you're going to end up with y equals 3. When x is 6, you can get 1/2 to the 1. Well, guess what? This is an opportunity for me to give you a modified rule. You don't want to use this. You don't want to calculate with a half. 2 to the 1/2 to the 1 minus 5. Okay. In this case, technically, it's going to work out to be a whole number, but a lot of times it's not. Okay. So when you have a fraction base, okay, don't use that. Use -1. Make the exponent -1. And here, so let's see why. If we make the exponent -1, then we've got to choose an x of 4. Okay, so now what we're going to see is 2 times 1/2 to the -1 minus 5 is going to be our y. Well, when you apply -1 to a fraction, you make the bottom and the top have a negative exponent, which means they switch sides. So the 2 goes on top, 1 on the bottom, and this is what you get. This is your y. 4 minus 5 is y is going to be negative 1. Okay? So this is very useful when you have a fraction base. When your base is a fraction, make the exponent equal to negative 1. All right. So here are 2 points. We have 5 comma 3, and we have 4 comma negative 1. And our asymptote, horizontal asymptote, is negative 5. Horizontal asymptote, negative 5. First point is 5 comma 3. Second point, 4 comma negative 1. So I made a mistake here, and this is actually going to be useful to point out to see how you rectify a mistake. You know, I had said at the top that this is going to be a decay function. I know it's going to be a decay or anti-growth because of that 1/2. It's really supposed to go down. And look, this is going up. What? Where did I make the mistake? See if you can find it. I'm looking at it right now. I realized 2 minus 5 is negative 3. So this graph doesn't make sense based on our knowledge of what the different parts of the function are. So let's fix that mistake. Yeah, so the moral of this story is don't just submit your answer after you've done these calculations. It's quite possible you might have done something wrong. This was supposed to be negative 3, and you know that because this is an anti-growth exponential function. That was a base of 1/2. And it did not get reflected because a reflection would make it look like this, okay? This is a reflected anti-growth. That's just a weird one. Okay, it turns things upside down. But given that this was positive, this should really be going down. So I'm fairly confident this is going to be correct. Okay, let's do one last one. Just looking at this function, I know a couple things, and it's useful to identify or predict the shape before you do it so you can check your accuracy, as we just saw. Here's something. This is growth because the base is 4, so it'll make you think that it's going to do this, but the A is negative. The A is negative, which means it's going to be reflected. This is the shape we're going to be looking for. And this also means that the graph is going to be below the horizontal asymptote. The horizontal asymptote is here at positive 5. But this is the shape we're going to be looking for. It's growth, but it's going down, which is all because of this negative in front of the 4, which reflects the graph. Okay? So let's first set our asymptote. It's horizontal, as always, for an exponential. And we're going to bring it up to 5. Okay, according to that. We don't have a fractional base, so we're going to let x be 2 things, the exponent. Okay, one of them is going to be 0, and the other is going to be 1. Okay. If exponent's going to be 0, x has got to be 5. Exponent's going to be 1, x has got to be 6. Take the scenario where x is 5. We're getting, now watch this carefully, negative 4 to the 0 power plus 5. Okay, let's follow order of operations meticulously. This happens first. 4, you take the exponent first. That makes this into a 1. Then you multiply by -1 or make it negative. Okay, the exponent happens first. 4 to the 0 is 1, then it becomes negative. Okay, so our y, in this case, is going to equal 4. Making the exponent 1, x has got to be 6. So we're looking at 4 negative, again, 4 to the 1 plus 5. Well, we take this exponent first, and that just stays a 4. So we're talking -4 plus 5. -4 plus 5 is, oops, +1. Okay, so the 2 points that we should graph are 5, 4, 6, 1. Let's see if that matches the shape that we are expecting. 5, 4, and then 6, 6, 1. So this does, right? We were predicting a shape that would take us down, that was also below the horizontal asymptote. Okay? So I'm thinking this is right. And by the way, this 4, besides the fact that it was negative, which reflects, it's also a stretch factor. Oh, I'm sorry. Totally wrong. That's the growth factor. Okay? Growth and stretch, I was going to say, are visually hard to distinguish. Because if you're stretching something like pushing it out up here and pushing it down here, that's the same as just accelerating the growth, right? In a way. So growth and stretch can be visually, conflated, but it's large. It's 4 times growth. But of course, it's anti-growth because it's been reflected. But looks very stretchy. Looks very stretchy. And so again, based on the predicted shape and our accuracy, hopefully, of this, I think we're going to be okay.